All right, welcome. Today, we're doing something a little different. We're going to peel back the layers of reality itself. We're going to look at the hidden world that underpins, well, absolutely everything you see, everything you touch, everything you are.
No, seriously, just think about it for a second. The chair you're in right now, the air you're breathing, even the light from the screen you're looking at. What's fundamentally holding all of that together? What makes it all work?
Well, the answer is in a world you can't see. In this world, it operates on a set of rules that are so bizarre, so completely counterintuitive, they basically laugh in the face of common sense. So, you ready? Let's peel back that first layer.
Okay, so to even begin to understand this hidden world, we have to shrink our whole perspective way, way down. Let's start with a simple thought experiment.
Imagine you could take anything, your hand, the desk in front of you, and just zoom in. I mean, really zoom in, past the surface, past the cells, past the molecules. What do you think you'd find at the very, very bottom of it all?
If you could keep going, you would eventually hit a scale that is it's so small it's almost impossible to wrap your head around.
Take a look at that number. That's a 10 billionth of a meter. It's a mind-bogglingly small distance, and that's exactly where we need to go. And at that scale, well, that's the size of a single atom. We're talking about the level of individual atoms and the even tinier particles that make them up. So, welcome to the quantum level. Yeah, this is the place. This is the ultra-tiny world where the physics you and I know, like a ball falling because of gravity, it just stops working. The rules don't apply anymore. Down here, nature's playing a completely different game. So, why the name? Why quantum? Well, it actually comes from a really fundamental idea about how things work at this tiny, tiny scale. Okay, think of it like this. In our world, if you walk up a ramp, you can stop at any point, right? It's a smooth, continuous trip. But in the quantum world, energy isn't a ramp. It's a ladder. An electron can be on step 1, or it can jump to step 2. It can never be in between the steps. These little discrete packets, these steps of energy, those are the quanta. And this is where things start to get really weird. Once you accept this whole steps on a ladder idea, the rest of the rules that govern this tiny universe are just wild. Let's dive in. All right, first up, wave-particle duality. So we all think of an electron as a tiny little ball, right? A particle. And it can act like one. It has a specific location. But it can also behave like a spread-out wave, something with a frequency. Now here's the crazy part. It's not one or the other. It's somehow both at the same time. It all depends on how you measure it. Wild, right? Okay, if you thought that was weird, get ready for superposition. This idea says a particle can literally be in multiple places at the exact same time. It's not in one spot, it's kind of everywhere at once in this cloud of pure possibility. But, and this is the kicker, the second you try to look at it to measure where it is, poof, it chooses a single spot to exist in. Just looking at it forces reality to pick one answer. And it gets even stranger. I want you to imagine throwing a tennis ball at a brick wall. It's going to bounce off every single time. Simple physics. Well, a quantum particle facing a barrier can sometimes just show up on the other side. It doesn't break through the wall, it just appears over there. This is quantum tunneling. It's like the particle has a cheat code for reality, letting it walk through walls it has no business getting through. And believe it or not, there's more. You've got the uncertainty principle, which basically says there's a hard limit to what we can even know. The more you know exactly where a particle is, the less you can know about where it's going. And then there's quantum entanglement. Einstein famously called it spooky action at a distance. It's where you can link two particles, and whatever you do to one instantly affects the other one, no matter how far apart they are, even if they're on opposite sides of the universe. Spooky is right. So, okay, we've got all these completely bizarre, seemingly impossible rules. But this isn't just some physics funhouse, some weird corner of science. This strange world is actually the engine that runs our world. Which brings us to the big question, the one you're probably asking right now. Yeah, I get it, it's weird, but who cares, right? Why does any of this matter to us? These rules seem so far removed from our daily lives. But here's the thing, they're not. At all. In fact, they are everything. The truth is, the quantum level explains, well, pretty much all of it. It's the reason atoms can bond together to make molecules. It's why chemistry works, period. It's how sunlight powers photosynthesis, feeding all life on Earth. It's the absolute foundation of all modern electronics. That computer chip in your phone, that laser in a scanner, all of it exists because of these weird quantum rules.
And here's the really big one. Without these weird quantum physics, atoms themselves just wouldn't be stable. They'd fall apart. Just think about that. The very building blocks of matter couldn't hold together. The universe as we know it just couldn't exist.
Okay, let's pull all this together. After diving into this bizarre and visible world, what's the big takeaway here?
In short, the quantum level is basically the universe's operating system. It's the base code. It's a place where particles can be waves, where they can be in many places at once, and where they can literally pass through solid walls. And those weird rules, they control everything.
So what does that mean for us? It means that this solid, predictable world you see around you is kind of an illusion. It's what bubbles up from an underlying reality that is governed by pure probability, uncertainty, and a whole lot of weirdness. And that's the thought I really want to leave you with. If our solid, tangible world is built on a foundation of pure uncertainty, a shimmering cloud of possibilities that only becomes real when we look at it, then what is truly real? It kind of makes you think, doesn't it?